All right. Let's talk about. Oops, you gotta take my pen. Let's talk about more graphs. We've talked about DT graphs, yes, just reviewing. If I have, let's make black. If I have a DT graph, yes, slope equals speed. Yes, we've learned that already. If I have a VT graph, area is equal to the distance traveled, or displacement, depending on what type of quantity we're dealing with at that moment. But the question is there other information that I can get from one of these graphs? And there is. You might recall from the last video that acceleration is equal to the change in velocity over time. And I can get change in velocity from the y-axis, and I can get the time from the x-axis. So if I have a graph that looks like that, and I'm interested in finding the acceleration here, it would seem as though I need to subtract the change in the y, delta v, from the change in the x. So let's say that I'm going to start at VI, and I'm going to go up to VF, yes, and that would be right about here on my graph, and here on my graph. So I need a couple values. I'll make it in green. I need this length right here is delta V, VF minus VI, VF minus VI, and this would be, this one right here would be, try and go along the axis as much as I can. This would be delta T, or just T. So, which is equal to the slope on a VT graph. So there's two bits of information that I can get from a VT graph. The area under it gives me displacement, or distance, and the slope of it gives me acceleration. Carrying on in a similar vein, I need to put a sign up. People keep coming to my office. What happens? Oh, I didn't want that. What happens if I look at an AT graph now? There's my T, an acceleration time graph. Even for this motion up here. If I found the acceleration at this part, I'd get a number, and since this is a straight line, the slope of this part of the line is equal to the slope of this part of the line, is equal to the slope of this part of the line, is equal to the this part of the line. So I would get straight line. Yes, that's a straight line in case you didn't know. And an AT graph, the area under it is the change in v, change in velocity, change in speed. You can calculate the slope of something like this. Slope of an AT graph is actually equal to, it's called jerk. It's not something that we talk about in this class, but it's called jerk. So there's all sorts of different information that you can get from these graphs. So make a little chart here. Type of graph, and you should probably have a copy of this in your notes. Area under and slope. So you should probably make a copy of this guy so that you have all the information that you need. So if I'm dealing with a DT graph, the area under it is nothing, and the slope of it is v. If I'm dealing with a VT graph, the area under it is d, and the slope of it is a. And if I'm dealing with an AT graph, the area under it is v, and the slope is nothing. It's actually a jerk. It's small. But it's not of interest to us. So this summarizes all the information that we can get from the different types of graphs, DT, VT, and AT. And you will have to do it on a bunch of